All right, y'all, welcome back. We're running it back to back. We're going to go ahead and do 8.6. 8.6, I will guarantee you, is a lot more easier and a lot more faster than 8.5 was. So let's just dive into it, okay? So we want to find the area of more than two intersections. So that means that we're going to be looking at potentially setting up multiple integrals and looking at different functions. In this case, we're dealing with two functions, so it's something that we've been used to doing. Let's go ahead and get started. Okay, so we got the functions f of x and g of x that create boundaries for multiple regions. So we have one region here, two regions there. Find the x values of points of intersection and label them from smallest to largest as a, b, c. So in this case, I want to solve for x and find all intersections. So in this case, I have my two functions. I have my cubic function and my quadratic, right? In this case, my quadratic is negative. It's an upside down parabola. Okay, I want to keep all those things in mind. So I'm going to have 3 x cubed minus x squared minus 10x is equals to negative x squared plus 2x. Boom. Set them equal to each other. I want to pass everything from my left side, from my right side to the left side. That way I make it as easy as possible. I'm going to end up with 3x cubed minus 12x is equal to 0. So all I did was pass the negative x squared. I did plus x squared. That gets canceled out. Minus 2x, negative 12x, right? So now I can see I can extract a 3x from the left side. So if I say 3x times x squared minus 4. Oh, I see I have a difference of squares here. Well, not a difference of squares. Is it squares? Sorry, I'm having a little bit of a brain fart moment, but I'm having a perfect square moment here where I can easily figure out the values, right? In this case, it's equal to 0. Whoops, come on. Is equal to 0. So I do my math on this side. 3x is equal to 0. Divide by 3. X equals 0, right? X squared minus 4 is equal to 0. I know that instinctively that this is going to be x is equal to plus and minus 2. So I have my two sets of zeros, right? So let's start setting them in order. My lowest value is negative 2. So my a is going to be negative 2. My middle value is 0. And then my upper value is 2, right? And that gives me those intersections here, right? So this would be my a value. This would be my b value. And this would be my c value. Okay. Now that I have that information, I'm going to go ahead and set up my integral. Let's start again. This is with respect to x. So with respect to x, I start with my, I take into consideration my upper graph minus the lower graph, right? So I'm setting up my integral. Let me scoot this up. You know what? I need to see my graph. Right there. That's fine. So I'll make it like this. This is from negative 2 to 0. And then my first one is my cubic function. So it's going to be 3x cubed minus x squared minus 10x minus my lower graph, which is my parabola with negative parabola. So it's going to be negative x squared plus 2x dx, right? Because that's where it ends. And now it gets me to my next checkpoint, which is b, from b to c. From b to c, it goes, so it's going to be plus my integral bounded from 0 to 2. My parabola goes up first, so it's going to be negative x squared plus 2x minus 3x cubed minus x squared minus 10x. And again, don't forget your dx. Boom. That's it. This whole thing is your integral setup. Now, you're probably wondering, Mister, we can do something easier. Well, yes, we can. We can do something easier. And we can do the absolute value. Remember that problem that we did with like the tank that was getting filled? And Alan was like, what's the difference between the velocity and the absolute velocity. Well, this is one of the cases where we can use the absolute value to figure out this whole thing, right? Without separating into two integrals, all that stuff. So I can literally just set up my integral from A to C, so from -2 to 2. But now I'll do the absolute value of f of x minus g of x. Close my absolute values and dx. Okay? Do not make this mistake, because you could do this, but it wouldn't work in this situation. Okay? So do not, I'm going to write it here. Do not, I'm going to put don't. Do not write it like this. Do this. Do not take the absolute value of the integral from A to C, blah, 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 and then do some gibberish here, right? Dx. Do not take the absolute value of this. This is not okay. Okay? So the absolute value bars go between f of x minus g of x, not taking over the integral. Okay? And that will literally give you the same thing. Okay? All right, let's look at number 2. We're almost done with our packet. All right, it says the figure below shows the graph of y equals 2 minus 1/2 x, and the line y equals 1 for values between -2 and 2. So they give us the bounds. That's good. Set up the integrals for the sum of the areas in the shaded regions. So this is telling me a few things. Based on my graph, I should have 3 integrals. I should have 1 integral, 2 integrals, 3 integrals. Okay. So now I need to find what my x values are for this point here and this point here. Luckily, I see that I have a parabola here. If I can figure it out for one side, I'll know it for the other side. So let's go ahead and solve. My line is y equals 1, so I can set up my parabola equation, which is this. So I'll say 2 minus 1/2 x squared is equal to 1. I go ahead and solve for x. So I'm going to be left with -1/2 x squared is equal to -1, because I subtracted 2 on both sides. And then from here, I'm going to multiply by a 2, or in this case, a -2 on both sides. So I can get rid of the 1/2. And I'll get x squared equals 2. I take the square root on both sides, and I get that x is equal to plus and minus the square root of 2. So that tells me that this right here, that tells me that this value right here is negative square root of 2, and this right here is positive square root of 2. Boom, those are my x values that I needed. Let's set up our integrals. All right, here we go. So my first integral, make sure you write small, because you're going to need a lot of space for this, for these long integrals. So it'd be -2 to negative square root of 2. Boom. Right here, I can see that I have my my upper bound is that one line, and that my lower bound is my parabola line. So I'm going to do 1 minus 2 plus 1/2 x 1/2 x squared. The reason I did plus is because you see how this is a negative? I would have to insert this as a negative. So it'd be 1 minus 2 minus 1/2 x, and I distribute the negative, and by distributing the negative, I get a positive 2, a -2, and then a positive 1/2, right? Hopefully you see that that's how that works. Dx, my next integral is bounded between negative square root of 2, so where we left off here, so negative square root of 2 to, so from here, whoops, where's my mouse? It goes from here all the way to here, so it's between negative square root of 2 to square root of 2. Boom. And this is bounded by my parabola, so it's going to be 2 minus 1/2 x squared minus 1 dx plus my third and final integral, The third and final integral is basically going to be a repeat of the first one, right? Because it's bounded between square root of 2 and 2. Nothing really changes, just the bounds on the integral. So it's literally the same thing. So it's going to be square root of 2, my apologies, square root of 2 to 2. 1 minus 2 plus 1/2 x squared dx. Hopefully you understood my chicken scratch right there. I know it's a little bit sloppy, but I'm trying my best. So let's see. And that's it. This whole thing is your integral. If they ask you to find an actual value, you just type it into your calculator. That's all you need to do. Okay. Other than that, we are done. This is it for 8.6. For the practice problems, please do all practice problems. So 1 through 6, please. Practice problems 1 through 6. Go ahead, take care of that, and then enjoy the rest of your spring break. I will see you in about a week and a half from now. So have fun, enjoy, do some work, prepare for your exams, because literally when we come back, we're going to wrap up chapter 8 like within a week, and then we have our unit 8 test, and then I want to do a mock exam. Also, don't forget, we're going to have our Saturday FRQ review day on the first Saturday once we return. Other than that, like I said, enjoy your break, and I will see you in class. Feel free to email me at any time if you have any questions, or if you want me to record something because something didn't come out the way it was supposed to. But then again, you can always double check your answers online. Y'all know how. Don't pretend like I don't. So I will see you in about a week and a half. Bye.